Hello and welcome to Bachmann Live. You already guessed it, this time our webinar will take place in English language. But don't worry, our speakers or presenters, Kirsten and Björn, will talk slowly, at least I hope so. They will introduce to you the advantages of the new Bachmann product, the Cantilever Sensor for rotor blades and tower. A few words to our presenters. Kirsten Larsen has over 10 years experience in the wind industry, and she's working as key account manager at Bachmann Monitoring, serving Bachmann's wind farm and operator clients for projects both on and offshore. Before joining Bachmann in 2019, Kirsten worked for more than 8 years as director of sales at Airwerk, a successful technical solution provider which designed and installed over 100 structural health monitoring systems in offshore wind parks, both Baltic and North Seas. Given this experience, Kirsten has a particular focus on structural health monitoring applications for the wind industry. Björn Naschwitz is also working as key account manager for Bachmann Monitoring, and he's a certified Cat2 vibration analyst. Previously, he served as the head of Bachmann's remote monitoring center in Germany, overseeing the performance of 8,000 wind turbine generators. In that time, he was also responsible for the software commissioning and training of the world's largest CMS retrofit project. Before joining Bachmann, Björn worked in research and development focused on acoustic-based driver assistance systems for automotive technology. He's an expert in CMS technology, vibrations and acoustics, machine diagnostics, and reliability-centered maintenance. If you have any questions, feel free to post them during the webinar in the Q&A section of Teams, and we will answer them directly after the presentation, or we'll come back to you later if there are too many questions to answer in this time. Now I'd like to hand off to Kirsten, and I wish you all a very interesting afternoon.
Thanks, Stefan, for that kind introduction. So Björn, we're going to do this?
Yes, let's start.
All right, great. So today we're here to do our first webinar for the new Bachmann sensor. It's a cantilever sensor that we call the Cls Sensor. And
yeah,
hand off to you.
Yeah, thank you, Kirsten. Before we go into the details of the new solution, we want to zoom out a little bit and give you a bigger picture about why we do and what we're doing. I hope Bachmann is familiar to everyone, so we don't want to go into details about Bachmann, but we want to explain to you that Bachmann believes in technology. That technology is one of the primary keys for a green future. But thinking about that sentence, actually 120 years ago, technology was also one of the reasons that we're currently facing certain situations in the world. So let's be more precise. Let's concentrate on wind turbines. So how can we contribute to the wind turbine business? So as Bachmann offering supporting solutions to those technologies, which are the control systems, which are SCADA solutions, as well as condition monitoring products. What does have all of those three products in common? And the majority of those in the audience who owns Bachmann, they know they are extremely reliable, they are secure, and they are highly functional. So today, we focus on the Cls sensor, and we don't want to touch all the other topics. So let's focus on the Bachmann monitoring and the condition monitoring product. So what we do exactly in that area. Let's go back in time a little bit. 20 years ago, we started with drivetrain condition monitoring for wind turbines. And at that time, some of the founders would be more precise, but the basic feedback you got is that condition monitoring is basically looking in a glass bowl, right? So it could be right, it could be wrong.
Right.
So, but over the time, the market got more mature and understood that condition monitoring is extremely important. So, and that was also for us really important to see development in that product. And so now we're concentrating not just on the drivetrain. We want to look beyond the drivetrain. We want to concentrate on an integrated health and usage monitoring. And what is that exactly? It is basically an holistic monitoring solution for energy plants, looking at the foundations of the turbines on and offshore, looking at the tower, and obviously looking at the blades. Back in the time, we looked at the market and tried to understand what are the blade sensor solutions at that time, and we figured out that we saw some limitations in those products, and we started looking at certain goals to develop our own product. And Kirsten will give us a little introduction to those goals.
Yeah, exactly. Thanks, Björn. You're right. When Bachmann began developing this new sensor several years ago, as Björn said, we started looking at the existing solutions on the market and looking for ways we could improve on that. And so first of all, we felt there was a need to have a sensor that is simple. That means, it has to use an industry-proven sensor and be easy to install. And on top of that, we felt it needed to get away from a dependence on a complicated signal transformation and use a direct signal. Then we also felt that any sensor that's going to be used to monitor the blade or a tower over the lifetime of the wind energy plant needs to be robust. You want to have a sensor that can hold up to extreme environments, for example, in the offshore market. Finally, any new sensor on the market has to be extremely reliable. That means it has to deliver very accurate and reliable data, but it also means reliability in terms of sensor failure. You don't want a sensor that's going to be very sensitive and have a number of different types of failures that you have to often maintain or repair. And this is especially important, of course, for offshore wind farms. So we've talked a little bit now about the motivation behind why we felt this would be a good addition to our holistic products, and also what were our goals in developing this product. But Björn, why don't you tell us a little bit more what exactly this sensor looks like?
Yeah, we'll do that. As you can see here, and I need to apologize up front because that word simple, we have to use it because it is simple. So, and I will explain you why. Basically, what we have is two pieces. We have the cantilever mount, we have the connected cantilever, and the cantilever has a target, and then we have another part or piece which is the sensor mount with the connected higher resolution proximity sensor. So and basically those are two parts, right? And you may have heard that quote that Elon Musk said, the best part is no part, and that's what we try to fulfill in that way. So it looks a little bit unusual for what you already know in the market for such kind of solutions. So what we try to achieve with that sensor is a concept transition or transformation from strain measurement towards a distance measurement, and that's what it basically is. We're looking at the distance, and just give you some ideas about the dimensions. So you can see the real product over here. The complete length is about 37 centimeters. The cantilever itself is about 27 centimeters, and the distance in between the proximity sensor and the target is roughly 1.5 millimeters. So that gives you a little bit of idea about what's the dimension. But how does it work? So the way or the idea to go from that strain measurements toward that distance measurements makes the principle extremely simple, right? What we do is we're looking at distance changes. So whenever your blade is facing loads, the distance will change. It will either get longer or it will shorten. So that's basically it. And again, it's simple. And there's certain reason that we did that. First of all, it's important that the output signal is completely comparable to what you already know for the strain gauge and for the fiber optic strain sensor. But the huge advantage is that, as you can see here, we are not connected to the surface. And that makes the CLS sensor not a subject to any mechanical and chemical aging. That's really important for the longevity, right? Mm-hmm. So, and that always guarantees, and that also guarantees the long-term measurement stability. So, and another big advantage about that solution is that we are also capable of being flexible with the length of the cantilever to change the measurement range or the resolution. So, but overall, we have a certain distance. And with that distance, we obviously minimize the influence of local inconsistencies where strain gauges obviously facing problems, because wherever you put it, you might have a different situation of the material.
Yeah,
right?
Exactly.
So now that we know how it works and how it looks like, Kirsten, can you help our audience to understand where we actually want to put it into the blade or the other objects where we want to put it? But now we concentrate on the blade.
Let's look at the blade first.
Let's do the blade.
Okay, great. Let me just move to the next slide here. Yeah, so we generally recommend that you install 2 of these cantilever sensors in each of the blades. One of the sensors is going to measure the flap-wise movement, and the other one's going to measure the edge-wise movement. And so basically, this is also pretty easy to install because you can see on the diagram here that the sensors are installed not very far away from the hub or the root of the blade itself. And so it's only actually about 1 to 3 meters inside the blade. And so this is a great advantage because it simplifies the installation. You don't have to have technicians crawling even further into confined spaces and laying cable even further down the blade in these confined spaces. So in our experience so far with the installations, and we are hoping for improvements, but at this point, to install these 2 sensors, just the sensors themselves, and to plug them to the wire, takes approximately 1 to 1.5 hours only. Of course, what does take time is the additional cable routing, out of the blade into the hub to where you're connected to data acquisition or to the PLC. Also it takes some time is the fact if you're installing in the entire turbine is that you have to rotate the blades so you can move to the next installation point.
So you're basically saying that with that numbers you said, with the times we need, one installation of a complete set for the complete turbine will take roughly 2 days, right?
Yeah, exactly. We're looking at about 2 days per turbine. All 3 blades are installed, total of 6 sensors, and connected to PLC or to your data acquisition system and commissioned.
So, that's amazing. But now our audience, they may have already faced several different solutions in the market. So, and I think they're pretty interested in how does actually our sensor compares to the rest of the market.
Right, exactly. Maybe if you just move to the next slide.
Sorry about that.
There we go. So as Björn just said, we did look at how does our system compare to, let's say, the fiber brag graded technology or acceleration-based blade monitoring systems. And unlike the other systems, the CLS 300 can be used for a variety of different cases. And that means it can be used for individual pitch control, it can be used for ice detection or damage detection. And this is an advantage because right now in the market, you might have one system that's doing the pitch control and another one that's looking at damage detection. And this way you have all of these uses all in one. The next issue that we found where we perform favorably is has to do with data quality. So with this very simple setup that we have, the measurement is not affected by the quality of the adhesive of the system. In addition, as Björn already mentioned when he was talking about how the sensor is set up, it's based on a proximity sensor. It's forceless, it's contactless. And so in comparison to these other systems, you're going to have less mechanical aging because the sensor itself is not touching and it's not bending. Finally, some other points that are important to mention here is that there is this direct signal. There's no need for an optical electrical transformation. And that means also you don't need any special devices for commissioning this sensor. And because we have developed installation processes and we have, for example, mounting templates, it's easy to install. It's much easier to install. It means it's faster to install. And we have step-by-step instructions that any normal service technician can follow to install these. So Björn, going on, you work primarily with OEMs. So what are they looking at in a new type of blade monitoring system?
Yeah. Indeed, I'm working for the OEMs, and the interesting part is I talk to a lot of different departments, and every department has different expectations, right?
Yeah.
We also put that in consideration, developing that product, and also being a main supplier for one of the OEMs with condition monitoring. We learned a lot in the process, and also where the challenges in everyday single departments. So Kirsten mentioned it already, but we have to say it again, and especially for the OEM, is important to also streamline or reduce the amount of sensors you've been using, right? So in getting the IPC information, the load information for IPC, a potential ice detection, as well as the anomaly detection from one sensor, that will relieve a lot of people, especially the procurement, obviously, right? Yeah. Because handling different vendors is always challenging, and then different products and versions and etc. pp. So that's one of the most important parts. And then looking at the production, we know that the OEMs they are also forced to produce cheaper and to levelize the cost of energy, and so the production get distributed around the world. So and the quality of the people in the production, they may be different from location to location. So we need to make the installation procedure as simple as possible and to reduce the error rates. And that's just one aspect, because once it's installed, you also need to commission it somehow. And especially commissioning can be challenging, especially in the field, right? If you're out in the field, it should work, and you don't want to carry like extremely complex, really complex measurement equipment, right, to test it, right, in the field. And not all of them can do that, right? It requires a lot of training, etc. So and our system, as we said, is straightforward. So we have a 4 to 20 milliamp current signal, which you can just connect to your I/O module, right? That's basically it. And another beauty about the Cls sensor, and that's what sometimes gets forgot in the process, that you don't want to just have an additional sensor or an additional software to monitor it, right? So you want to use the correlations and the possibilities and solution you already have in your turbine, like a condition monitoring for the drivetrain. And if you can correlate and you can use the information from both worlds and combine it, that brings the condition monitoring to a complete different level, right? And it's always a goal for us to, as I said, beginning to create that integrated health and usage monitoring. So, but circle back to the production process. So we want to show you a short animation which gives you an idea how you could install the Cls sensor into the blade and to make it CLS ready. So what basically happened is you have your surface, you put some glue on it on the right positions. You can use some templates for it, which we have already available to make that installation as simple. And then you have that mounting aid, and you use it, just install it at that position, which means the system is basically already aligned, so you do not need to do anything else. And then you just add in the field or in the production, it depends on what is your procedure. Right. You know, you can, it's at the end, it's your decision. But then you just connect the two mountings with the cantilever and the sensor to the pre-installed connector, and that's it, right?
Yeah, exactly.
So yeah, that's the benefits for the OEM. So Kirsten, you primarily work with the operators and utilities. So where do you see the benefits for those customers?
Yeah, exactly. Yeah, and thanks again, Björn, for kind of focusing on these, what the aspects are that are important for OEMs and for utilities, operators, independent service providers. There's a different focus, particularly for these utilities or the operators. They're focusing at the bottom line on maximizing their return on their investment in this wind farm, basically. And so, you know, the rotor blade component is one of the more expensive components of a wind energy plant. In fact, just to give you some numbers there, a 60-meter blade is going to cost you about 200,000 euros to replace that blade. And that doesn't include the cost of the cranes, the cost of labor, the cost of actual downtime. You're not producing any energy, you're not gaining any revenue at that point. So that's something to keep in mind. And basically, and this is something Björn and I were talking about earlier today, that's the cost of a 60-meter blade. We're talking about a lot longer blades these days on the market, especially offshore. So you can just imagine how costly that becomes at the end of the day. Another thing that operators are focusing on or really considering is the fact that the blades are going to come with about 1 to 2 years of warranty after installation, and they might have a design life of up to 20 years or more. But think about that. That leaves you a long period of time where you're out of warranty. So there you need to maintain this asset, right? So you need to watch out for repairs and have inspections and eventually start planning the replacement. So just to give you an idea what planned maintenance and the value of this type of monitoring data is for planned maintenance. I just saw some recent data that said that the cost per technician and day for planned maintenance is going to be about 750 euros a day. That's just for one guy. And if it's unplanned maintenance, those costs go up to 1,000 euros per technician per day. And then start thinking about unplanned crane costs. That just means you have downtime because you may be waiting to get a crane and you may be waiting to get a replacement blade or repair materials. So there's a lot of cost information that's going into the considerations for the operators, for example.
Yeah, and as you know, right, bringing up all those examples, I mean, thinking about the OEMs, at some stage, the OEMs also becomes an operator, right?
Right.
So depending on their service agreements and also during the warranty period, they acting as a kind of operator, and and also for the agreements, they look out for their own turbines. But then nowadays, the majority of the OEMs also looking into the multi-brand service strategies.
Right.
So that means they are pretty familiar with their own turbines, but then taking over the service for another turbine and maybe do not know that much about it, supporting technologies like condition monitoring for blades and for all parts of the components will help them significantly.
Yeah.
Wouldn't you agree?
Yeah, totally. I totally agree with you. And that's a good point. That was something I'd kind of forgotten, that OEMs are more and more playing this role of operators themselves. So basically what we're saying, that not only for OEMs, but also for operators, it can make sense to do a retrofit installation if there isn't this, if the sensor isn't installed directly during manufacturing, let's say, by the OEM. And so why we think this is a good option is because, as Björn explained before, we've thought about the installation process a lot when developing this sensor. So we wanted to make it kind of CLS ready, so for a manufacturing type of situation, but also for existing wind farms where it can be retrofitted. So we had to think about how can we make this simple so that, and fast, and as least expensive as possible, so that you can actually consider retrofitting your blades with the CLS. And as we said now several times probably, the service technicians that install these don't need any special training or certification. And we have developed, as you can see on the diagram here at the bottom, we have a template that we've developed that any service technician can use to properly position and mount the CLS sensor. So with that in mind, why don't we look now at how a retrofit type of installation might look like, and show this little film. So at the bottom, you have the surface of the blade. You have an adhesive. We have a mounting aid that's used to position the sensor. This is what it looks like underneath this mounting aid on this sheath. But you can usually keep that cover on the sensor, and that can also serve as step protection in the blade.
All right, perfect. So we learned a lot now about the benefits and how the solution works and how it looks like, right? But let's review the use cases. We already teased a little bit. So obviously, the main intention was to find a sensor for the blades, and with certain use cases in mind, newer turbines, getting longer towers. No, what is it?
Taller towers.
Taller towers.
I like taller towers.
Yeah, I was like, yeah, definitely taller towers, and the blades getting longer. So the customers, or especially the OEMs, they need to be they need to concentrate more on getting a little bit carefully about the material, because material is expensive, and the taller the towers get, you do not need to you do not have to use that much material, and also for the blades, they get in longer and longer, so you need to reduce the loads. And you need to use the material. So IPC can help a lot to overcome those new dimensions we're talking about. And also, you can use it for maximum load control. And also, knowing about the weather conditions and all the environmental conditions, you can basically create a load history by post-processing all those data you have. As we said, as one of the use cases, we're looking at ice detection, and currently we have several installations in the world, all around the world, preparing the measurements and the results for certification purposes. So, and the detection of structural abnormalities will be then the last step we're looking into. And there, obviously, we have a lot of experience with the drivetrain condition monitoring, where we basically went through the same process where we looked for certain excitations we didn't know, we learned about it, we analyzed the failure and the damage, and then we created really smart KPIs around it to be able to detect it in the future. And so the same approach we will do for the sensor as well, and for the structure abnormality detection. But I mean, you are an SHM expert, right?
Yeah.
Structure health monitoring expert. So, I mean, what else could we do with that?
Yeah, exactly. I think maybe I already mentioned it before, but we can also use this sensor basically as an alternative to strain gauge sensors. And so we have been using this already in some projects on and offshore as an alternative to a strain gauge installation in the tower, in the foundation, again, to measure the structural health of the tower. And just to give you an idea, what our first experience has shown, in particular offshore, for example, in that case, because it was a pilot project, we went head to head with the strain gauge sensor. And so we installed the Cantilever Sensor, and next to that also strain sensors. And what we found is that the Cantilever Sensor is much easier to install. You don't have to damage any, for example, corrosion protection as you do with typical strain measurements. And we found, in fact, in this particular case, we had 1 to 2 extra days installation time offshore because of difficulties in installing the strain sensor. So that's just one example why we think this is a great option also for doing measurements in towers.
Perfect. So let's circle back a little bit and to the motivation and also what we actually want to achieve with the solution we are providing. So what we want to have is that holistic solution where, as I said, we want to combine all the data flows we see into one solution and use advanced algorithm and to post-process them, but in a holistic way, you know, and to be able to create really smart KPIs, which we then can use to feed them back to the PLC and vice versa. Obviously, it's always a back and forth, so you have to exchange that information. And the beauty about Bachmann is that if you have a Bachmann electronic control system in there, you basically can combine everything as you wish. So we have the fully integrated condition monitoring solution, and then if you would have the blade sensor as well, or the tower sensor, right. So you can combine everything and can make your turbine much more advanced and smarter when it comes to the control itself. Do you have some more points?
Yeah, let me just add too that if anytime you have access to this wealth of information from the drivetrain, from the blade, from the tower, this is going to give you a real databases for optimizing your O&M activities, for one thing. To also, what's important is a databases for perhaps extending the lifetime or the service of your wind energy plant. And I think that's a real clear advantage as well.
Right, right. All right, I think
we've come to the end of our first webinar.
Yeah,
Björn.
first live
webinar for the CLS sensor. And I want to say thank you to everyone for joining us online here with our first CLS sensor webinar, not seminar. And I just want to let you know a recording of this presentation will be made available to you. We can send that to you, and look for an invitation in the not too distant future for a workshop, which probably will go into more technical detail on measurement capabilities with the CLS sensor. So as we're at the end of our part of things, Stefan, do we have any questions we should address from
Yes, indeed. So
the audience?
Thank you for the presentation. We have a lot of questions, and therefore I think it will be very helpful to have this workshop go deeper in technical details.
I think so too.
I have summarized a few, but not all. One thing is it goes around the question of electromagnetic interference. Björn, can you tell some?
Yeah, sure. That's a question which I face, and you probably as well, doing some of the meetings we held in the past. And yeah, we are aware of that situation, right? It's a cable-bound solution, and we need to make sure that we do not have any interference by lightning strikes or lightning effects. So we already did extensive testing with an independent service provider who's specialized of such kind of analysis, and there we did some induction tests to lightning currents and also surge tests, and we passed it successfully. So our audience can be sure that there is definitely no influence on the electromagnetic interference.
Okay, thank you. Another question, is the CLS certified, and what do end users need to consider regarding certification?
Okay. Maybe I can address that for you, Stefan. That's something that's come up with some utilities and operators that I've spoken to about this solution, let's say for ice detection, et cetera. And we are in the process of getting certification for this product. And in terms of what do operators need to start thinking about in terms of certification, there's several things, and it can be a little bit complex. Number one, you have to look at what your operation permit is for the wind farm, what is allowed. Sometimes it's not very clear what you can actually retrofit that's actually hooked up to the controller, for example, for automatic stopping and starting of the turbine. And on the other hand, you also have to interface with the OEM, the manufacturer of the turbine, as well, to see maybe they have a pre-installed EO where the sensor can already just be connected to it, and that's already been certified as part of their type certification. So there's a few things you need to investigate, but we would be happy to talk to anybody who needs some support in that area.
Okay, thank you. And another question, how is the issue of temperature compensation dealt with?
Yeah, that's an interesting one, because we faced that several times already. So it's really interesting that we see the same questions coming up. But there's one thing about the simplicity. Yeah, we have that saying, we said it's simply clever. So in clever is because the temperature compensation is actually integrated in the concept. So, and what does it mean? The cantilever itself uses a certain material, and the material can be different, and can be different in a way to match the material of what we want to measure, right? So that we have a similar coefficient of thermal expansions of the material with the cantilever.
Yeah.
So, and that works pretty well. But if there are more requirements and people or customer want to see more, a different way, or maybe they are not completely sure about that, we can also add always a temperature sensor, for instance, right? And we can use that information to then do the post-processing to compensate that temperature influence.
Okay, thank you. Another one, does it work, the CLS, does it work as a standalone sensor, or will it need a Bachmann CMS?
Yeah, I mean, you can use it both ways. Let's put it this way.
Yeah.
So, obviously, as we said, the data output is 4 to 20 milliamp. And if you have an I/O module in the hub where you can connect the signal, then you can use it for the PLC. Then you not necessarily need a Bachmann device as a data acquisition box.
Okay.
However,
Of course, we recommend.
sure, yeah, yes, of course, you're welcome always to buy a Bachmann box. But yeah, of course, I mean, as Kirsten said, we're talking about retrofit, and retrofit means we are facing, first of all, different turbines in different phases of their life. It could be really old turbines, and obviously there's not always I/O modules in the hub. So, but then in this case, we can add a Bachmann PLC with different I/O modules, and we are flexible in that regard. So yeah, definitely, that's a good question. But yeah, automation technology as a basis always helps.
Yeah.
Okay. Yeah, that's it for now. I have to say thank you for your presentation.
Yeah, thank you.
It was a pleasure for me also, and thank you for the audience, and hope to see you soon. And we keep you informed about the additional workshop where we go deeper in technical details and can answer questions that we are already in overtime that we can't answer right now.
All right.
So, thank you.
Thank you so much also from our side.